So here's some practice problems for the inverse cosines. And I printed these out. And so I'll let you know, you can refer to these, but I'm going to just walk through a couple of them. Okay, and the first one says don't use a calculator. And so you might want to use the famous value. So I suggested a table, and this is what I was thinking of. So the first one is the tangent inverse of square root of 3 over 3. And if you see that, you notice that you find that right here. So our answer is going to be theta equals pi over 6. But one way to reason through this is the tangent of theta, tangent inverse of square root of 3 over 3 equals theta, where tan theta is equal to square root of 3 over 3. And then I go and use the table. Okay. So here's another one. This is 1a. This is 1b. Sine inverse of 1. Now I'm looking to see where the sine is 1. So theta is going to be pi over 2. But the way to think about it is that sine inverse of 1 equals theta, where sine theta is pi over 2. And again, right there, theta is going to be pi over 2. Okay. Now the next one, 1c, is going to be cosine inverse of 0.5. You look for 1/2, right there. So that's going to be pi over 3. And again, cosine inverse of 0.5 is equal to theta, where cos theta equals 0.5, and then I look at the table. The reason I'm doing that is just kind of to reinforce the concept. So here we have one that's mixed. I have the sine of the cosine inverse of 1/2. Okay, well think about this. The cosine inverse is going to give me back an angle. Sine of that angle is going to work. Okay, so I know that the cosine inverse is going to be square root of 3 over 2. So that's the sine of square root of, of pi over 3. Cosine inverse of 1/2 is pi over 3, so I just plug in pi over 3 for that. And then I look for my table and I see, okay, that's going to be square root of 3 over 2. Okay. Now, E and F are trickier, so you don't need the table for that. So E is going to be the tanverse of the cosine inverse. The tangent, 1E, is the tangent of the tangent inverse of 15. Now that's going to be equal to 15. This is going to be like something like the log base 10 of 10 to the 3 is equal to 3. It's exactly the same kind of idea, but let's go through that. So the tan inverse of 15 is equal to theta, where tan theta is 15. So I'm going to say, okay, tan inverse of 15, the tan of the tan inverse of 15 is going to be equal to the tan theta, where tan theta is 15. Well, that's tan theta, that's going to be 15. They just cancel. Okay, 1f cosine inverse of the cosine of pi over 10. Okay. Now, we don't know what the cosine of pi over 10 is, but they're going to cancel. And again, I'll go through this theory. The cosine of pi over 10 is equal to a particular ratio whose angle is pi over 10. So the cos inverse of the cos of pi over 10 is going to be the cos inverse of a ratio whose angle is pi over 10. Cos inverse of the ratio whose ratio is pi over 10, well, that's going to be pi over 10. No matter how you get it, you can think of them as canceling, or you can kind of reason through it. I like to reason through it because I think it's useful. Okay. So for the next ones, I say use a calculator. And I'm going to show you a tool that we haven't used that much. You could use Desmos, but I'm going to use something called Wolfram Alpha, and I have it right here. And let me clear that. Okay. So I actually already have the answer to that one, but If you haven't seen this before, it's just wolframalpha.com. So let me write that down. Wolfram Alpha, one word, .com. And it's kind of a cool thing. It's like a calculator, but it's got a lot more things to it. But so I'm going to just type in tangent, caret, minus inverse, and then it's going to be square root of 7 divided by 2. Okay, what that's going to give me, let's see what it looks like. So that's going to be this. Yep, that's right. That's going to be this. It doesn't come out. Remember, the tangent inverse of a ratio is going to be an angle. The angle isn't a great angle, but it's giving you the result in radians. So we would have 2a tangent inverse square root of 7 over 2, and that's equal to, let's do the three decimal places. That's going to be 0.923535 rounds to 4. Okay, so 2b is going to be the sine inverse of 0.35. Now remember, the way I get the inverse was the caret sign, so I could do this. Sine inverse of 0.35. Let's see what it gives me. Okay. Again, that gives me an angle. It's 20.49 degrees. So this would be equal to, again, we'll go to 3 decimals, 35757, 0.3575. That's going to round to 8. Now I could also do this, and I think this is why some people like the arc cosine or the arc sine, because it doesn't, you don't have to do any fancy typing for exponents. And we get the same answer, but, oh, this should be the arc sine, no wonder. My bad. So the sine inverse of 0.35, yep, same answer, okay, which we should get. I was looking at the next problem. The next problem is going to be 2c, the cosine inverse of 0.25. So let's look at that. Again, I'm going to write arc cosine and 0.25. And notice how it just gives you the answer right here. But let's just go through it and see. So again, I get 1.3181. That's going to be 1.318 to 3 decimals. Okay, so I will stop the share, and I just wrote down the answers that we got. So we have those. Okay. Again, that's a handy way to do things. Okay. So problem number 3 talks about something called the angle of repose, which sounds really nice. And the notion is, if you make a pile of a lot of things, like sand versus corn versus water versus concrete, it has an angle of repose, and that's kind of where, because of the weight and everything, that's the basic shape of the pile. Like water's an extreme. If you just try to make a pile of water, it just flattens out, so it has no angle of repose. Sand might have a different one than corn. Rocks might have a different one than sand. So the idea is that we pour a bunch of corn, like imagine pouring it into an elevator or something like that, and the corn forms a pile that looks like this. Okay, so it's kind of like a cone, and it's 20 feet high, and it's 94 feet across. And we want to find that angle. That's the angle of the repose. So again, I'm going to look at this. And this is the angle that we're looking for right here. Now, 94 is this whole thing, so I need to divide 2 by 94. I get 47. That's what this is going to equal to. So now I have a 20-foot triangle. So I'm going to look at the ratio. I have the opposite over adjacent. So I know that the tangent theta is going to be 47 over 20. So the tangent inverse of 47 over 20 is going to be my angle. And I'm going to go back to Wolfram Alpha and do that. So we'll do a quick share screen. Go back to Wolfram Alpha. Since I have it up, I'm going to do the arc tan just because it's easier to type than typing in everything else. And it was the arc tan of 47 over 20. And that said theta was equal to 1.168 radians. And if you go down, it gives you the angle, and it's 66.95 degrees. Okay, so I'll stop the share just to give you the answer there. So that was what we did. Okay, hopefully that makes sense. The next one is number 4. It's also a geometric one. So we have a tall building. I'm not going to try to draw it. That's going to be 500 feet high. And then we're standing right here, 100 feet. Okay. And we want to find the angle of elevation. Now, I could measure it from up here, and that complicates matters because how tall am I, and that shortens the building, but we're going to measure it from the ground. So this is the same kind of problem. We know that the tangent theta is equal to 500 over 100, which is 5. So we want to find the tangent inverse of 5. So I'll go back, share the screen again so we can do that. Arctan is the same as the tangent inverse, and we said 5, so we get 1.373. And again, that, to me, that doesn't make much sense in radians. I have to go to angles. I know it's going to be a little bit bigger than 60. It's 78.69. So in terms of degrees, that would be 78.69 degrees. Okay, so again, I'm going to go back, stop the share. I just wrote down the answer. This was our picture. This is what we set up, opposite over adjacent 5. We looked this up, and we got this many radians. And again, you don't write radians, but I kind of like to do it sometimes, just so we know what we're talking about. And then that's the degrees. Okay. So we got one more set of problems, and these practice problems, and then we're done. So number 5, it says, find the functions in terms of the following triangles that are in standard position. So here's what I'm thinking of. This is what I mean by standard position. And the first one says adjacent side is 3, hypotenuse x plus 3. Okay, that's A. We'll do these separately. B, that triangle is going to be opposite side is 4, adjacent side is 2x minus 1. And then C, opposite side is 4, hypotenuse is 2x minus 1. Okay, so these are the ones we're going to do. So I'll start with A. So A, here's our triangle. And it says write as a function of x. Write the angle y as a function of x. And the way I translate that is I want something that looks like that. Some formula right there, a formula with x as the variable. So a formula and x. So again, so I look at this and I say, okay, oh, what if I look at that? Let's see, opposite over hypotenuse. So I have, okay, so the sine of y is going to be equal to 3 over x plus 3. Okay. Now I want to get y alone. So what I'm going to do is I'm going to take, I want to solve for y, and I want to have that equal x. So what I do if I take the sine inverse of both sides, oops, that's the sine inverse of the sine. That cancels. And I'm going to get y equals sine inverse of 3 over x plus 3. That's my function of x. Okay. Okay, that gives me the angle. Okay. Again, this isn't that crazy. For B, here's the triangle. Okay. And again, I have to figure out a ratio. Well, it looks to me like the tangent of y is equal to opposite 4 adjacent 2x minus 1. So I need to get y alone. So I'm going to use that fact that we used earlier, that if I take the inverse tangent of both sides, those cancel, gets rid of the y, and I get y equals tangent inverse of 4 over 2x minus 1. Okay, I got one more to do. Okay, so here was C. Here is my triangle. And it looks like, I think I did A, I did adjacent. Oh, you know what? I did A wrong. I'm going to go back and do that. This is correct. I have to go back and redo A because I had the picture wrong. We'll go back and fix that. So here I see that the sine of y is equal to opposite over adjacent. And I do the same thing. Sine inverses of both sides. Sine inverse and sine cancel for reasons we saw earlier. So that's going to be my y as a function, my x as a function of y. And the last one is going to be to do the part A again. Part A, I wrote it wrong. It says adjacent side is 3. I had it over here, over x plus 3. And here's my y. So now it's going to be the cosine ratio. So we're going to see the cosine of y is equal to 3 over x plus 3. Okay. And then what I need to do here is I need to hit both sides with the cosine inverse. That'll cancel out the cosine on the one side. Those cancel, and I'm going to get y equals cosine inverse 3 over x plus 3.